Good afternoon, ladies and gentlemen. It's my pleasure to be here to present on behalf of SMISS. And you are the ones stay till the last, because I'm the last one of the session. I hope I'm the last, but not the least. First, I have to introduce myself. I'm Cherry. I'm not Agita in the list, also not Jackie. I'm Cherry. I'm so sorry that Jackie, just before his departure, he have got COVID-19 again. So it's me. It's like I have been entrusted at the last moment to deliver this speech. But thanks a lot for our R&D team and also our research institute. We have done a lot of research on the ceramic coin technology of iHeat. So here I hope you can hope through my speech you can know more of what we have done. And also the gentleman, the questions he asked now, maybe from our presentation you can see some of the studies you want. Okay, let's start. Okay, my presentation divided into 3 parts. The first one is the background introduction. The second one is our studies on aroma compounds. The third one is our research of heating coil. Okay, the first one. Why we are thinking about doing this research? Because as we are here, our main topic here is the reduction of harm. So for us, because we already focused on e-cigarettes industry for 11 years, we are also thinking about what we can do, for the harm reduction. Oh, sorry, it's just moving so fast. So as e-cigarettes manufacturer, this is our expertise. We think what we can do is to make our products become the best alternatives for the smokers who quit smoking. So that's the background. So I don't know for older people here, I have to do a small investigation. Can you please raise your hand if you are vaping? If you are using e-cigarettes, anybody here? Nobody using e-cigarettes here? Okay, okay. Maybe you are not facing the pain that many of our customers facing. So this is also the background. We can see from here. Okay, so right now, for the e-cigarettes consumers, when they are vaping different flavors, they are facing a lot of pain. So we have listed main ones here. The first one is the insufficient reduced degree or insufficient purity of the tobacco flavors. Because what we want to do is we try to work on tobacco flavors because we think tobacco flavor will be the best alternative for the smokers. As you can see right now, there are a lot of places, such as the US have the flavor ban, and in China last year we also have the regulation. We only can sell tobacco flavors in China, and also in Europe, a lot of countries also have the tobacco ban saying like that. So we think we should more focus on to develop the best device with tobacco flavor. But for tobacco flavor, actually is more complex and harder than the normal fruit flavor, and we suffer a lot of the tobacco flavors, such as I mentioned here. It's not, the purity of tobacco flavor is not so good compared with the cigarettes that you use. The second one is, the flavors changed after you keep inhale, maybe for 20 times, you will feel the flavors changed. The third one is you may face in the burnt taste, which is, very bad. You will feel you choke or you have a throat rasping or like that. The third one is you cannot have the, the satisfaction as you are smoking, such as you don't have sufficient smoke or, the richness of smoke is not enough. The third one is you will not have the satisfaction of licking. So that's all the pains the people facing. And then with all these things that people are facing, because we want to improve this situation and to make the best tobacco flavor e-cigarettes. So we have done a lot of studies of the aroma compound studies, and we found out have 3 features. The first one is for tobacco flavor, it have more components. And the second one is have the higher vapor conditions. The third one is have higher e-liquid boiling point of the substances. So these 3 points have caused it's much harder or tougher, to be optimized. We have listed down here the next slides. You can see from here the aromatic composition comparison between classic tobacco flavor and fruit flavor. On the left, sorry, I try not to move the laser pointer. On the left-hand side we have listed down the classic tobacco flavors without PGVG and nicotine. You can see we have 110 ingredients here, while the right-hand side is the fruit flavor. You can see only have 31 ingredients. That's a big difference. So in order to let consumers have the authentic tobacco flavor, we have a lot of more, that's 3 times more ingredients, compared with fruit flavors. Okay, this is a comparison you can see from here. Just now for our, ICCPP also have mentioned about the e-liquid boiling point, because this is also really a very important part, to reduce the harm. So you can see from here for classic tobacco flavors, we have 57, which weighs 51.8%. This e-liquid boiling point is below 200 degrees Celsius. And there are 53, which is more than 200 degrees Celsius. While for the fruit flavors, 18 out of 31, which weight 58%, is below 200, and another 13, which is more than 200 degrees Celsius. Then from here, when we are studying for the aroma compounds, the viscosity, also very important for the flavors. For the viscosities, we can see from this slides, the right side you can see, if we have high viscosity of the liquid, it will cause to poor fluidity. And if poor fluidity will cause lower speed of the absorbance. And this will increase the risk of dry burning during the optimization process. And if you have the dry burning problem, the heating cooling is easy to accumulate the carbon residue. So this is really bad, for our health. So which will affect the flavor and produce, harmful substances. This is not we want. The feature 3 is we can see from here. This also, I think they also mentioned previously for the temperature. This is the vaping temperature is very important factor during the process. So we can see from here for classic tobaccos, the maximum vaping temperature will reach, 394.2, which is about 400 degrees. And the minimum is 21. For fruit, is 342, while 76. So we can see that for classic tobacco flavor, the temperature is much higher and the range, the difference is much bigger. So this is a summary, as we said just now. I will not mention much here. So with all these issues, so what do we need to do and what's our solutions? So in order to avoid the issues we have and to make the best products, so we have done a lot of research on the heating coil and also try to develop of the electronic control technology to ensure the authentic tobacco flavor. That is what we can do. Let me show you what we have to do here. As you can see from these slides, this is the heating coil research. This is the most widely used traditional, the coils we have used. Maybe I'm not so sure if you have using the vaping products or you know these components. This is a very important item for us. The first one is traditional cotton heating coil. Second one is the embedded technical ceramic heating coil. The third one is the mesh cotton heating coil, which is the most popular one for disposable products in the recent 2 years. And the last one is the thick film printing technology ceramic heating elements. So this is the main ones in the market, but we found with all these 4 main types, which still cannot give us the best, the tobacco flavor. So that we have done a lot of research on the heating materials. The most important, of course, is the ceramic. So we have chosen the FTA food-grade ceramic materials, as we can see from the first one. And maybe it's really hard it's a bit hard to understand. The first picture, the black dot there is you can see there. This is is FDA certificate powder particles, which is easy to dissolve. And after we choose the material, we have done the test. We also have to do the mechanical, test. The second one is we have done a lot of tests in the laboratory of if we are puffing, for 3,000 cycles, we will detect the smoke change. And the third one is we have choosing, this is very important part, is the S316L stainless steel material. Later we'll introduce one by one, you can see from the later slides. The first one is about the ceramic coil we have chosen. When we choose the ceramic coil, it's very important is it need to have the unified cavity distancing distribution, and also have to have uniform e-liquid conduction. That is two very important points for us to choose the ceramic coil. So we can see from the picture here on the left-hand side, we can see if we micro-structured it of the ceramic cavity to be 2,000 tons. You can see the structure there is quite uniform, and the size is all similar, like 20 mil. The second picture there is we put it 5,000 tons, so we can see, and the one at the right side, you can see the top red line there. This shows 99% of the porosity is 20 mil. Okay, so with all these studies, what we want to reach is the higher e-liquid conduction, of the heating coil. So besides for the ceramic coil, so here is another important element is this one. We also pursuing for continuously optimized ultra-thin distance between the e-liquid surface and the optimizing surface. So before, normally the products in the market, the distance between e-liquid surface and the optimizing surface is about 1.1 mil. But for us, we have made it to be 0.8, so which means we have actually, shortened it for 30%. So which will have more effectively improved the liquid conduction tons. The next one is also, I think, is quite also important for this part. Is we have used the double layer production of the heating film. So this the heating film we use here is the mosaic structure, so that we have no problem. We are long wrapped and also continuously film structure, and the temperature resistance is 600 degrees Celsius. And also, as we mentioned previously, we have used stainless steel material S316L. This is also, we can see from the picture at the right side here. This is a TCR test result. The resistance value of the heating film is, here you can see, is quite, stable. Okay, with all that mentioned, we also have to do a lot of tests, to see how is the performance of the products. So we also have done the temperature field test. From the result that we have got of the temperature field result, we found out that under 7.5 watts power output, the heating profile is ultra stable. We can see from picture at left-hand side here, it's quite stable. And also the thermal imaging temperature field here, you can see the analyze. The maximum, just now we also mentioned here, is about 250 something. We can see from here temperature also quite stable, is between 254.6 to 251. So it's also quite stable. That is what we want. We don't want temperature changing too fast or too big. So with all the analysis we have done, so we want to have products which have the best tobacco flavor taste and to avoid all the pains or issues we have just now. So we have developed one product which is anti-dry burn technology and preventing the burning coal to meet the requirement of tobacco flavors here. The second one, we also, for the one we used for iHeat technology, the ceramic coil we choose also have uniform cavity distancing, which is 20 mil. And also the porosity, the standard hole is up to 99%, as I mentioned previously. That is quite important to have the stable products. And the third advantage of our new technology we want to develop is we have high speed e-liquid absorption because we can see from in the middle here, in the middle here, we have do some comparisons of our iHeat heating coil compared with other heating coil in the market. You can see that the porosity and, you can see the porosity and the water absorption. This ratio is quite similar. The big difference is the e-liquid absorption rates you can see here. So the other products in the market is about 0.4 milligram per second, but our iHeat heating coil will reach 2 milligram seconds, which have a very, very big difference. And also, I don't know why it just moves. And also from the full picture, you can see from here, actually I felt not good to see the picture, it looks very bad. The first two at the left-hand side is using our iHeat ceramic heating coil. Oh, sorry. So sorry, what happened? Somebody is controlling. Okay, at left-hand side are our iHeat ceramic coil, heating coil you can see from here. The first one is we have draw 3 seconds, stop 27 seconds for 1,000 puffs. You can see from the picture, you didn't see much change from the surface. The second one is after 3,000 puffs. And the third one is the other heating coils. After 1,000 puffs, you can see some changes on the surface. It's already showed carbon accumulation. The last one is after 3,000 puffs. You can see very bad, the accumulation of the carbon on the surface of the ceramic. So this is very bad, will cause harm to the body. So this is the picture of the products that we developed based on our concept and our ideas. We have developed these products. So if you are interested, you also can come to our stand R2 to see the real products. Yes, thank you.
Thank you very, very much, Cherry, and I really appreciate that. And I also apologize for my appalling timekeeping. I haven't controlled the audience enough, and I'm sorry that... I'm really sorry. I'm going to have to ask you to take questions to Cherry outside, and thank you very, very much indeed. And I'd like to thank Cherry and William just now, and all of the others beforehand. I think it's been a very, very interesting and informative afternoon. Mm-hmm. I've clearly got a hell of a lot of work to do to persuade others of my view that the technology is absolutely central to this. But thank you to all of you. So let's all of us give each other a clap, I think.
Thank you. Thank you so much. Have a nice day.